Good morning, all. I'm here at my kitchen table again to give you the notes for the last two sections on Khan Academy that are currently due. This is for the area of a parallelogram and the area of a trapezoid. In either case, we're going to be starting with our basic idea of the area of a rectangle, which is our length times our width. Now, the key thing to note about this, the absolute critical understanding that you have to have about this particular formula as we extend it towards finding other shapes, as we use it to actually build practical knowledge that's beyond looking at a formula chart, the key understanding you must have is that the length and the width of a rectangle are measured at 90 degrees. Those two measures are perpendicular to each other. And as we go through finding the heights or the areas of every other shape, we are always going to be measuring these at 90 degrees. So when we go to triangles, we talk about their altitudes, which is why right triangles were so easy to find the area of, because they had that visible 90 degree. And as we look at parallelograms and trapezoids, we are again going to be looking for or measuring, specifically looking for that 90 degree so we can determine what our height and our bases are to find those areas. So the first thing I would like to point out here is that I've got a ream of paper, a stack of 500 sheets of paper, and I'm going to be visualizing the side of this stack as a rectangle right now. So this means what I'm looking at, or what I'm considering now, is that this is the length of a rectangle going all the way across here, and this is the height of a rectangle or width of a rectangle going across here. So the area of this shape would be this distance multiplied by this distance for my length and my width. So to visualize this rectangle instead as a parallelogram, what I'm going to be doing is simply moving this thing over. So after using my other hand to rearrange this, you can see now how this shape is a parallelogram. Now the important thing to notice about this is that the area of that shape did not change. I didn't add or take away any more area. And so if I were to calculate the area of this figure, I still need to do it the same way. I still need to find the area of the length times an area of the width. But that width is not measured diagonally. This is the number one mistake that is made when people try and find the area of a parallelogram that's following the area of a rectangle. The height or width of this is not measured diagonally. It still needs to be measured up and down. So back to that critical understanding I said at the start of today, the one thing that must be true, our length and width must be measured at 90 degrees to each other. So we could use from here all the way across to here to find the length of this, but when I do the height to find its area, I must measure so that this distance is at a 90 degree angle to this. And then it is simply a rectangle in that regard, and we'll do the area of the length multiplied by the width to find our area. As for a trapezoid, its formula is a little bit more hairy. I was looking for a good way to animate this online, but apparently the rest of the world doesn't think about this the same way I do, because I wasn't able to find one. I found a bunch of different weird in my view, ways to find the area of a trapezoid, but I'm going to present the way that makes sense to me. So for the area of a trapezoid, you must first know that a trapezoid has two bases. These bases are always parallel to each other, so base 1 and base 2, it does not matter which one is longer and which one is shorter, or on top or on bottom. What matters is that those two lines are parallel to each other, not the ones that are at some sort of slant and, if extended, would intersect. But the two sides that are parallel are our bases. The height of this is, again, of course, as always, our key idea for all of our areas, measured at 90 degrees. So the area here not the area. The height here is measured perpendicular, that is at 90 degrees intersecting each of our bases. Now I've started to draw some purple lines on this paper to show the way that I'm thinking about this. I am looking at this as a rectangle in the center with two triangles on the outside. Those rectangle heights are the same height as the difference between the bases, still measured perpendicular. And when I'm looking at this, what I'm thinking of is I'm thinking, how can I change this shape that I've got here to be the same as a rectangle? Because rectangles, again, are really easy. It's just base times height. And for me to be able to square out, make 90 degrees, the sides of this trapezoid, what I'm thinking of is I'm going to think about making base 1 longer and making base 2 shorter, sort of turning those slanted sides on the edges, the legs of my trapezoid to be perpendicular. And it's going to look something like this. So here I've drawn, again, purple arrows to show how base 1 would have to be stretched out to be longer and base 2 would have to be shortened in order to make this become an actual rectangle. So the key question then is, how much longer or how much shorter would the bases have to be to become the same? And really, it's the average of the two. That means that I need to take the length of base 1 and the length of base 2 and add them together first, and then divide that by 2. Be very careful with parentheses here if you're using an online or unfamiliar calculator. We have to add them first and then divide that by 2 to find the average. And now I can use that average base multiplied by the height to find the area of that trapezoid. I've written down here at the bottom 2 common ways this formula appears. Again, keep in mind that the B1 and B2, or A and B, for either one of those commonly written formulas are the lengths of the bases that are parallel to each other in this trapezoid. And yes, this works for isosceles or irregular trapezoids. So I hope that gives you the information you need for the last 2 assignments currently in Khan. We have been instructed to post assignments weekly, so this is going to wrap up everything for that first week, and you can anticipate new assignments and instructional content towards the end of next week. I can see a lot of you are doing a lot of the work on Khan Academy already, so thank you for that. It makes my job a lot easier when we don't have to start looking at making individual phone calls to say, hey, your kid's not working yet. Those kinds of things are planning to start next week as we start to work through this time. Again, please remember to take care of yourselves, stay safe, and hope to see you soon.